Okay, for this type of problem, what we're going to do is we're going to evaluate the limit as x approaches 3 of 2x minus 4. So the first part of it is to find the limit, L, and the second part is to find a delta so that this piece right here holds whenever this piece. Now the second part's going to be hard. The first part will be pretty easy. So if we graphed this guy out, the 2x minus 4, okay, just looking at the graph of it, so we're going to see that this is down 4 with a slope of 2. So it's going to look something like this. And so we want what is the value when x equals 3. Well, we can find this by direct substitution. So the height value here is going to be at 2. So it looks like as x approaches 3, the limit should be 2. Again, you can find that just by direct substitution here. So now what we're going to do is we're going to find a delta. Okay, so this is the easy part, our L value. This, by the way, this 2 is our limit value, our L value. So here's what we need to do. We need to come up with a delta. Okay, so we don't know what that is. But we need the following to be true. We need the function f of x minus the limit to be less than 0.01 whenever our x values minus 3 are less than that delta value. So basically what's going on here is we're constructing an area around 3. Our x values have got to be very close to 3. That's what this absolute value means. It means how far away from 3 are your x values. So we want the difference between our x values are floating in here around 3. We want the difference between them and delta, okay, excuse me, the difference between them and 3 to be less than some small amount delta. So out in this direction, positive delta, in this direction, negative delta. So that gives me this area here, or that length. I also make sure that it's greater than 0 because if it was greater than or equal to, if it could be equal to 0, okay, if that was the situation, then x could actually be 3, and we don't know if the function is defined at 3. In fact, we don't care if it's defined at 3. We only care what it's doing around 3. So let's plug in here what we know. We know that f of x is equal to 2x minus 4, and the limit we believe is 2. So we want that to be less than 0.01. So this guy reduces to 2x minus 6. Okay, I'll worry about this side in just a second, but this guy right here reduces to this, which reduces to 2 times x minus 3. We can pull the 2 out. And what we're trying to do is we're trying to make this guy inside here look like this guy over here, and we've done that. And you should always be able to do that when you're working with these epsilon delta proofs. So our epsilon value is 0.01. And now what we're going to do is we're going to look for what does x minus 3 have to be between to make sure that this guy is less than 0.01. Well, to make sure that this is less than 0.01, x minus 3 has to be less than 0.01 divided by 2. Now I divided by a positive, so I don't have to worry about the signs here. So let's pull this back up over this way so we've got a little bit more room. If I take 0.01 and I divide that by 2, that gives me 0.005. So that means that x minus 3 has to be less than 0.005. And what we've now found here is our delta value. So that means delta should be equal to 0.005. So if you took any x value that was within 0.005 of 3. So here's what I mean. Let's take a look at our x values. So this is the big picture. This is the answer right here. But the big picture is this. If you picked an x value that was less than delta, okay, it's distance from 3 less than delta. So what I mean is this is 3.005 and this is 2.995. If you picked an x value that was somewhere in that range, okay, then the difference between the function evaluated at x value and the value to the limits will be less than 0.01. So here's what I mean. If you grab a number in here, like let's say we grabbed this number right here, 3.001. Okay, it's certainly in this range. So if you take 3.001 and we plugged it into the original function, which is this right here. So let's do this over here. That's going to be 2 times 3.001 minus 4. That's 6.002 minus 4 is 2.002. The distance between this guy and the limit is 2, so the distance between this and the value 2 is 0.002, and 0.002 is certainly less than 0.01. So all this says is that if you pick a guy in here, its distance, when I plug it into the function, away from 2 will be less than 0.01.